To understand how materials work at its core, we need to learn about physically based rendering. Physically based rendering, or PBR, is a method of shading and rendering 3D objects that provides a more accurate and consistent looking results under different lighting conditions. The principles of PBR were first introduced by Disney and Pixar for use in offline rendering and animated films. But advances in the hardware and software have made PBR possible in real-time video games as well. Game engines like Unity and Unreal, as well as 3D art applications like Maya, Substance Designer, now use PBR. The standard shader in Unity, which was introduced in Unity 5, supports physically based rendering. Now let me show you an example of PBR in Unity. Currently in our scene, we have applied a material called as Material 3D to our 3D object. So I'm going to select the 3D model, and now I'm going to apply a material called as Wood. So I'm just going to drag the Wood material from Materials folder to the Material slot in the inspector window. And then the Wood material will get applied to our 3D model. Now I'll hit the play button. Physically based rendering simulates the natural interactions of light rays, thus giving us more realistic and consistent looking materials under different lighting conditions. So to demonstrate, I'm going to try change the lighting condition of this scene. Currently the scene represents the bright sunny day, and now I'm going to try make it look like a sunset scene. So first of all, I'll select the directional light. And I'll adjust the intensity, so I'll increase this value to 1.3, somewhere around 1.3, and then I'll change its direction to get some long shadows. And finally, I'll change the color to a warm orange tone. With PBR, the materials will always look the way you would expect, regardless of these lighting conditions. Now, that might not sound like a big benefit if you are new to making games, but before the introduction of PBR, 3D game artists were only able to create textures that look good under specific lighting conditions, and as soon as the lighting or the environment changed, artists would create another set of textures for the same asset. The standard shader in Unity, which is a PBR shader, will always consider the surrounding environment before rendering an asset, and thus giving us a consistent artwork that will look good in all lighting conditions. PBR makes use of a concept called as energy conservation. It states that the surface of an object should not reflect more light than it receives. So when light hits an object, some of that light is absorbed and gets converted into heat energy, while some of that light gets reflected. Different surfaces will absorb or reflect light in different amounts. These reflected light rays are the reason why objects are visible to our eyes. Now, the math behind such concepts and PBR in general is indeed complicated, but that is something we never need to worry about, as the standard shader in Unity does all the hard work for us. However, it is important to note that energy conservation plays a key role in PBR. Now, materials can be easily classified into two categories, metals and non-metals, and that is because metals tends to reflect larger amount of light than non-metals. In the materials folder, we have a metallic material called as gold. So now let's apply this material to our 3D model. So again, I'll select the 3D model and then just drag the gold material into the material slot. And let's play the game. This gold material doesn't just reflect its surroundings like a metal, but also looks like an actual metal. Unity standard shader does all the necessary calculations to make an object look and reflect like a metal. That's why it is very important to know whether the material we are creating is a metal or not a metal. We'll talk more about this later in the course. Another important factor in PBR is the microsurface detail. In Unity, this detail is represented by the smoothness map, which is also referred as roughness or glossiness. To demonstrate, I'm going to add the wood material back to our 3D object. So this time I'm going to select the wood material and drag this material onto our 3D object in the scene view. Now select the wood material so that we can see its properties in the inspector window. Currently the smoothness value is set to 1, and if I play around with this setting, and now if I drag this value towards 0, notice how the object looks like a dull surface that doesn't reflect much light. And if I drag it back towards 1, it will look more shiny. The smoothness or microsurface represents the irregularities at the microscopic level which can cause light to reflect in a varied manner. Rougher surfaces like concrete, wood will cause light rays to scatter around, giving us larger and dimmer looking highlights. While the smooth surface like a mirror will reflect light more uniformly and thus giving us more focused and clear reflections of the surrounding environment. While working with materials in Unity, there are two PBR workflows that we can follow. They are commonly known as metallic roughness and specular glossiness. We'll cover these in detail later in the course, but one thing to note is that by default, Unity Standard Shader uses the workflow that is very similar to metallic roughness. So that was it for this video. Now we have some basic understanding about PBR and the Standard Shader. In the next video, we will talk about some basic texture maps that can be used with the Standard Shader.